Okay, this is the Unit 9 test review for PreAP. Please excuse my voice. I'm not feeling all that well. All right, so here we go. The time it takes you to get to campus varies inversely as your driving speed. Averaging 20 miles per hour in bad traffic, it takes you 1.5 hours to get to campus. How long would the trip take averaging 60 miles per hour? Okay, so on this one, what you want to make sure you do is you always have to find that constant first. And remember, to find that constant, we do k equals x times y. So for now, it says the time it takes you to get to campus, so that's your y. So y varies inversely as your driving speed, so that is your x. All right, so my driving speed was 20, and then it took me 1.5 hours to get there. So that means that my k is 30. Okay, so to write the equation, I can write it as x times y equals 30. Or remember, you can also write it as y equals 30 over x. Okay, so to solve this, it says, how long would the trip take averaging 60 miles per hour? So again, my driving speed is my x, so I'm going to do y equals 30 over 60, and that gives me 1/2 hour, or 30 minutes. Okay, on number 5, does the data in the table below represent an inverse relationship? Well, I can tell that it's going to be an inverse relationship because when I multiply every single one of these, it's always going to equal 1,800. And I can also tell that as this is going up, this is going down. So that's another way to tell if it's an inverse relationship. So it says, if so, what is the constant variation? Well, remember, to find that k, we just do x times y. Doesn't matter which one of these I choose because they're all going to be 1,800. And so my constant k is 1,800. That's what my k value is. That's my constant. Okay, on this one here, it says the graph is a translation from the graph of f of x equals 5 over x. Write an equation for the new function. So on this one here, what I want to look at is, first of all, they're using a 5 right there. So I'm going to do g of x equals 5 over. Now, it's all about the asymptotes. So I can tell that this vertical asymptote is at x equals 1. So down here, that's going to look like x minus 1 because it moved to the right. Now, the horizontal asymptote went up 2, so plus 2. All right, on number 7, it says where are the transformations and asymptotic restrictions on the function of f of x equals 1 over x minus 4 plus 2. So again, this moved to the right 2. So the restriction, the right 4, that's supposed to be a 4, woohoo! All right, so I know that the vertical asymptote is x equals 4, which means that's a restriction. This one went up 2. That's my horizontal asymptote, which tells me that y cannot equal 2. So remember, these are also part of your domain. So I could say the domain here is like all real numbers except 4. And then my range here could be all real numbers except 2. So again, remember, those are all related. Okay, I'm not going to do the whole thing. So I'm going to skip down here to 9 through 12. If you look at let's say you look at number 9, it says what would be the new horizontal or vertical asymptote if the function f of x is replaced with x plus 5. Okay, so the biggest thing to remember is that when you're doing this, you're moving around the asymptotes. So this is your parent function, and the asymptotes always start right there. So it's saying f of x plus 5. So this moved left 5. So if I move this left 5, you'll notice it's not my horizontal asymptote that changed, it's my vertical asymptote that changed, and it moved over to x equals -5. Okay, if you take a look at number 12, I'm going to take my asymptotes back to the parent function. 12 is asking the same question, but this time they're giving me f of x and then minus 4. So on this one, this is actually moving down 4. So again, it's all about the asymptotes moving. So I'm going to go down 4. So I'm right there. So the only thing that changed was the horizontal asymptote. So y equals -4. Alright, on this one here, it says write a function with a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 5. So I'm just going to use, just going to put a 1 on top, just like the parent function. Now this says that it's x equals 0, so you just need an x right there, and that's a positive 5, so plus 5. So this one's very similar, except remember if you move to the left, it's going to look like an x plus 5. Alright, on this one it says what values are not in the domain. So in order to do that, I'm going to have to factor this x squared minus 25. So that gives me 5x over x minus 5, x plus 5. Okay, so what values are not in the domain? Well, here I know that x cannot equal 5, and here I know that x cannot equal negative 5, because that'll make these equal 0. So here, which values are not in the domain? I can say all real numbers except negative 5 and 5. Alright, on this one down here, for each graph, state the transformations applied to the function, write an equation, and state the domain and range. So remember, the domain is all about what the VA is, the vertical asymptote, and the range is all about what the HA is, the horizontal asymptote. Alright, so I'm going to use this again. I'll do this one over here. So this one I'm noticing if I start the parent function, well, I'm noticing that my horizontal asymptote isn't going to change because the curve approaches it but doesn't cross it. So my horizontal asymptote here is at y equals 0. But then I do need to move over my vertical asymptote. So the vertical asymptote is going to be at x equals negative 2. So if I write my domain, remember this would be for the domain because it's an x value. So the domain is negative infinity to negative 2, and then negative 2 to infinity. And then my range, again, is the part of the horizontal asymptote because it's a y value, would be negative infinity to 0, and then 0 to infinity. Alright, keep going. Alright, so on this one here, when you sketch the graph of each function and state the domain and range, excuse me, the domain and range. So on this one, what I'm going to want to do is, it's all about the movements. So for instance, on this one, I know that the horizontal asymptote moved up 3, so up 3. So I have an HA at y equals 3. And I know that this one moved right 4. So I have a VA at x equals 4. So again, if you go back to using this, I'm going to start where my asymptotes are at the parent function. And then I'm going to move it up 3. So 1, 2, 3. And then I move it right 4. And so it's right there. Okay, so that's where I want to draw my asymptotes. Alright, that's my horizontal one. And then I'm going to draw my vertical one. And then at this point, I'm going to put a point right here and a point right here. And then I'm just going to sketch the curve. Okay, I'm not worried about making it perfect, but it should not cross the asymptotes. It should come close, but it should not cross. So there's my curve. Alright, on these down here, it says write the domain and range for the following 3 functions in interval notation. For what value of x is the function undefined? So, aka, what are the asymptotic restrictions on the domain? So again, the really important thing to remember is the domain is all about the VA, the range is about the HA. Now, it does become a little different when there's a hole. Remember, your hole is an x and a y value. So if there's a hole, remember this x value also has to be part of the domain, and this y value must be part of your range. Okay, so if I take a look at this one, if I find the vertical asymptote, I'm going to put, I know that x would have to be negative 2, because negative 2 plus 2 is 0. So that's my vertical asymptote. I also can tell that this is bottom heavy because of the x squared. And so when it's bottom heavy, the horizontal asymptote is at y equals 0. So again, the vertical asymptote is all about making this a bottom part undefined, so making it equal 0. Okay, so my domain here is, again, it's just going to be the x value. So negative infinity to negative 2, and then negative 2 to infinity. And then my range here would be negative infinity to 0, and then 0 to infinity. All right, so let's see. So on number 25, again, I'm going to find my VA. So if I make that equal 0, it's going to be 3. Now my HA, I notice that these x's are the same, so I just take that first number. So this is my vertical asymptote. So the horizontal asymptote is at y equals 2, because remember, you just take this 2 over 1 and it becomes 2. So your domain here would be all real numbers, except the x value, 3. And then the range would be all real numbers, except 2. Okay, on this one here, you're going to have to do a little bit more factoring. So in order to do the factoring here, I'm going to keep the x minus 2 on top. It's nothing to factor, it's just a factor. And on the bottom, I'm going to have x plus 3, x minus 2. Okay, so remember, when you have this here, you really also have a 1 on top. So I can tell I have a hole. So that's going to be part of my domain and range. So the x part of the hole is 2. So now I need to find the y coordinate of the hole. So to find the y coordinate, I substitute in what's left. So I would put a 2 here. And remember, there's also the 1 on top. So to do the y coordinate, I'm going to do 1 over. There's the 2. So 2 plus 3. And that gives me 1/5. Okay, so this will be part of my domain because it's an x value. And this will be part of my range. Now, again, it's bottom heavy because that's a squared and that's just an x. So I know that my HA is at y equals 0. Now the VA, I need to look at what's left. So to find the vertical asymptote, I'm going to do x plus 3 equals 0. So x equals negative 3. So that's my VA. Okay, so when I do my domain and range, I'm going to do I'll do the domain right here. So my domain for this one would be negative infinity. And then if I'm going from left to right, remember I'm using this x here and this one here. So I'm going to hit this asymptote first. So negative 3. It'll pick up at negative 3. Then it's going to hit the hole at 2. And then it's going to pick up at 2. And then it's going to go all the way to infinity. All right, for the range on this one, again, you always start at negative infinity. I'm going from low to high. I got a 1/5 here, and I have a 0 here. So if I'm going from low to high, I'm going to hit the 0 first. I'm going to pick back up at the 0. Then I'm going to hit 1/5. Then I'm going to pick back up at 1/5 and head to infinity. So that's a lot more work on that domain and range, just because you also had to find what the hole was. All right, on this one here, let's take a look at this one. So on this one here, it says state the vertical and horizontal asymptotes. There's holes, domains, range, x and y intercepts. So of this one, there aren't any holes. And the reason I could tell there aren't any holes is because there's not two same factors that are the same. Now for the vertical, I'll do the horizontal. For the horizontal asymptote, so all I'm looking at is this front part here. There's a 1 in front, so it's just 1. All right, for the vertical asymptote, I'm just going to take this x minus 4, and if I set it equal to 0, I find that my vertical asymptote is 4. So x equals 4. For my x and y intercept, actually let me do the domain. So for the domain, I'm just going to use this, because that's my x value. And then for my range, I'm going to use the horizontal asymptote, because that's my y value. All right, for the x-intercept, remember, for the x-intercept, that's when y equals 0. So in order for this to equal 0, that means your numerator has to equal 0. So for the x-intercept, I'm going to do x minus 2 equals 0. So x equals 2. So this is going to be at 2, 0. And then what I'm going to do is I'm going to find my y-intercept. And remember, that's when x equals 0. So I'm going to take what I have here, and then instead of x, I'm going to put 0 minus 2. And instead of the x there, I'm going to do 0 minus 4. And that gives me negative 2 over negative 4, which reduces to 1/2. Alright, so here I would have a point at 0 and then 1/2. Okay, so to graph this, it's really just going to be more of a sketch. So I'm going to put the vertical asymptote at 4. Okay, and then I am going to put the horizontal asymptote at 1. Now, what's nice about this is I also know that I'm going to have an x-intercept at 2, 0. And I also know I'm going to have a y-intercept at 0, 1/2. Okay, so that's going to be one of my curves. And then for the other curve, it's going to be pretty much about the same, and I'm just going to sketch it on the other side. So all I'm really worried about is y'all just kind of sketching them. On the test, you will not be required to graph one of these by hand. Let's see. I'm going to skip to the other side. There's already a similar problem. Okay, so on this one here, again, it's already been factored for you, which is really nice. So I can easily see where the hole is. So this one will have a hole. So I'm just going to kind of write everything down. It's going to have a hole. It's going to have a VA. It's going to have an HA. That's enough information to tell me what the domain is. It's also enough information to tell me what the range is. And then my x-intercept and my y-intercept. Okay, so to do the hole, remember I'm looking to cross out the same thing on the top and the bottom. So that gives me x minus 3 equals 0 and x equals 3. So for my hole, so far I know I have a 3. Then what I'm going to do is I'm going to take what's left to find the other part. So that's my x. So to find out what's left, I have x plus 2, but instead of x, I'm going to put 3. Okay, so this is 3 plus 2 over. And then on this one, this is what's left over, so 3 plus 5. And that gives me 5/8. So the y-coordinate would be 5/8. So this is all for the hole. All that's for the hole. Okay, so really, I already know if I were to write my domain as all real numbers, so all real numbers except, so far I know 3 from the hole. I could also do the same thing for the range, all real numbers except 5/8. Now, I also need to find out what the vertical and horizontal asymptotes are to finish off what the domain is. Alright, so for the vertical, I'm going to take what's left on the bottom. So that's what's left on the bottom. So I'm going to put it equal to 0. So x plus 5 equals 0. So x equals negative 5. So my vertical asymptote is at x equals negative 5. Now for the horizontal asymptote, I'm just looking at these first ones and I notice they're the same. So in front of there is a 1. So 1 over 1 is just 1. So the horizontal asymptote is at y equals 1. So to finish my domain off, it'll be all real numbers except 3, and then also the negative 5 from the vertical asymptote. And then the range will be all real numbers except 5/8, and then the y part of the horizontal asymptote. Alright, to find the x-intercept, it's all about making the equation equal 0, which means the numerator has to equal 0. So to find the x-intercept, I'm going to take what's on the numerator, what's left, it's all about what's left, equals 0. So for this one, x will equal negative 2. So my x-intercept is at negative 2, 0. And then my y-intercept, remember that's when x equals 0. So what I'm going to do is I'm going to take what's left. So what's left on top is x plus 2, but I'm going to do 0 plus 2, because the y-intercept is when x equals 0. On the bottom, I'm going to do 0 plus 5, and I find it to be 2/5. So the y-intercept here is 0, 2/5. Okay, so to graph it, I'm going to do the vertical asymptote at negative 5. and the horizontal one at 1. I also know that I have an x-intercept at -2, 0. Okay, and I also know I have a y-intercept at 0, 2/5. So this graph will look something similar like this. Okay. And then this one here, I can just put this one on this side. Although I may want to check this one. Again, y'all aren't going to have to do these by hand. They're really a pain because then you have to start like substituting in numbers and then finding it out from there. So let me just kind of give y'all an idea. Like if I were to put this one in the calculator, I do also need to put my hole actually, so give me 1 second. And I could already tell, so I have a hole at 1, 2, 3, and then a little bit up here. So there's a hole actually up there also. Okay, so if I were to graph this one, it would be x plus 2, x minus 3. I kind of feel like that curve may not be in the right place. Let me just check that one. And then x minus 3, and then x plus 5. Oh, nope. Okay, nope, that's good. All right, very good. And like I said, you are going to have a hole. So you will have a hole there. So the hole's at 1, 2, 3, like somewhere around here. You're going to have like an open dot, and that's where your hole is going to be. So that's what the graph looks like. All right, so on number 23 on this one, you're going to want to factor. It's going to be very, very similar to this one that I just did. So once you factor it, you're going to get x minus 4 and x plus 2. And then you're going to get x minus 3 and x plus 2. So again, it's going to work out just like this one here. Again, you'll notice that your hole is right here. So really just kind of start off right there with finding your hole. And then once you get your hole, then start just kind of going down the list of everything you need to do. And again, remember the key's online. So use this one to help you. Do this one by yourself and then check the key. All right, on these last few here, we're just talking about like transformations. So on this one, I can tell that this is going to be a vertical compression. Okay, by 1/2. And then this also moved down. So down 5. Now, if I were to write with the vertical and horizontal asymptotes, just by looking at this, I could tell that the VA is still at x equals 0. But I know the horizontal one moved down to y equals -5. So on the next one, it says state the transformation. So this right here would be a vertical stretch. And this moved right 7. Okay, and again, if I do that, since it only moved to the right, I know that my HA would stay at y equals 0, and then my VA would turn into x equals 7. All right, on this one down here, it says what values are not in the domain. So anytime they're talking about not in the domain, that's related to undefined. It can also be related to a hole, or it could even be related to a vertical asymptote. Okay, so here, I want to factor that, so I get 3x squared over x minus 4, x plus 4. So for this one, I would have a vertical asymptote at x equals 4, and then this one, I'd have a vertical asymptote at -4. So for this one, I could say -infinity to -4, and then -4 to 4, and then 4 to infinity. Or I could say all real numbers except -4 and 4. All right, I hope this helps you. You know, please get help from your teachers if you need it, and good luck on the test.